This is a video demo for Azure Traffic Manager where we're going to show you how it works and we're going to show you how to set it up. We're going to show you in that order. You might know what Azure Traffic Manager is if you're watching this video, but just to outline for the purpose of this demo, you would use Traffic Manager to improve the availability of local applications, local servers, to improve responsiveness for end users, or it actually makes your servers easier to maintain. Where you could, if you had an RDS farm, for example, you could drop an individual server out of that RDS farm to maintain it, to patch it, to upgrade it, to test. You can route traffic to those devices, to those servers, based on a number of different criteria, based on priority. So effectively similar to DNS, you could have a primary and a secondary server, and all traffic's routed to the primary server until the primary server fails, and then the secondary server takes all the traffic. Or a weighted system where you evenly distribute traffic amongst your servers. So if you have 3 servers, you'll make sure that there's an even number of clients connecting to each server. Although the most widely used feature is based on performance, so that's latency. So effectively, when you run a DNS query, Azure Traffic Manager reports the server that's most responsive back, so your user gets the best possible performance, purely based on geographic. So if you're a multinational company, or if you have servers in different countries where different people are connecting to them, it will route the traffic to the service or the server that's closest to them or in the same country as them. Okay, I have 2 test servers set up for the purpose of this demo, running IIS, so we can connect to a website, not really a website, but the standard IIS splash page. One of them's in the East US and the other one is in West Europe, and I've labeled them slightly different. So if we go to the US one, I've changed the IIS splash page to incorporate US. Well, you can see if you refresh that, you just get itself its own web page. And the EU one, I've just marked it EU. So if we go to the US server, for example, which is obviously a server in the US, and I tell you what, let me show you this in the portal. In the portal, Azure Traffic Manager, when you set up Azure Traffic Manager, we'll go into the setup a little bit later, you do get a DNS name in Azure. So if we copy that DNS name, I think I already have it labeled on one of the sites, but if we go into the US server, yeah, there it is. So if we refresh that page, we're going to get the US server. It is the US server that we're actually connected to, so it's clearly going to connect to itself. That's where it's going to get the highest response, and I have my settings based on response. So if we go to the EU server, it should connect to itself as well through that website. Yeah, so there you go. If I go to because this is a routable DNS name, if I go to my PC, so there's the 2 servers, we're on my PC now. If I connect to the site from my PC, which is in the UK, it connects me to the closest server based on performance, as in latency, and it connects me to the EU server. Now we're going to show you the setup, and then we're going to show you how you can fail over. So what happens in the event of a failure of that EU server, because obviously, like most of Azure services, it's all about uptime guarantees. Let's go into the portal. There you go. So okay, so back to the portal, we show you the Traffic Manager profile. There's not much here that needs to be set up. So what I'm going to do is I'm going to delete this, and we're going to set it back up again so you can see exactly how that works. Yeah, so we're going to delete this Traffic Manager profile and set it back up again, just so you can see how that works. Okay, into my resource group, and we're going to add a Traffic Manager. I'm going to call that test traffic. Routing methods based on performance, which again, as I mentioned before, which is basically on latency. That's the easiest way to demonstrate this. Once we've set it up, it's the easiest way to show you how it works as well. In the resource pool that I've already set up, and we're going to create that, and then we're going to show you the settings. Okay, it doesn't take long to set up, and there it is. Test traffic. So we go into there and show you the configuration. Routing methods based on performance, we can change that afterwards. We have DNS set to 5 minutes, which means the DNS name that I showed you before, the external routable DNS name, is set to 5 minutes. So if that fails, you're not going to get the site. We can lower that, or we can heighten that. I'm going to, for the purpose of this demo, I'm going to bring that down to 30 seconds. We're going to monitor the endpoints based on HTTP. Actually, we'll just base it. So it's going to monitor the endpoints through its web service. It's just going to look at the route path and report back to see if you can see that there's a website up and running. You can take that to a specific website. If you know what the website is, you can put the path to that website in. 30-second failover, 30-second probing interview, but interval, sorry. But 3 number of tolerated failures. So for example, it would have to fail, it would have to report back a failure 3 times every 30 seconds. So in other words, in 1.5 minutes, it's going to take for that server to trip out. So for example, if you're routing to a primary server and that primary server is offline with the settings that are currently in here, after 1.5 minutes, that server is going to report itself as not available anymore, and you're going to route to the secondary. That's entirely you, what settings you put in there. I'm just going to change that to 2 just for the purpose of this demo. Just makes it easier for me to fail it over quicker. Okay, from here we're going to go to the endpoint screen. We're going to add some endpoints in. Now those endpoints are going to be Azure servers, and we're going to call it test endpoints. We're going to go to an IP address. You can go to an Azure cloud service. So if you have a hosted website through Azure as a service rather than on a server, you could go to Azure cloud services. There's various other cloud services that you can adopt from Microsoft Azure as well. But we're just going to link this to the public IP address. And the public IP address that I've set up is mptest, which is for my US server. And we're going to also set up the IP address of the EU server. EU. Okay, so those servers, as you've seen, are up and running. Here they are. So it's not going to be long before Azure sees those. It's just checking the endpoints to make sure everything's okay. You can see them. It's going to report them back as online, and once they're reported back as online, we should be able to connect to those using this DNS name. Okay, there they are online. So now if we'll just go back to, let's go to the overview, and we'll copy this DNS name. We should be able to route that immediately from Azure. So if we go to here, it's obviously a different domain name to what we used before. I'll just put that in there, test traffic. So that test traffic, that DNS name is reporting back on the US server as up, and it directs me to the US server. On the EU server, it should change that. It should take me to the EU server because it's the closest. So that's working. Now on my PC, if we change that, it takes me to the EU server. So my PC's in the UK, and we're connecting to the DNS name of the Azure Traffic Manager service, and Traffic Manager has reported back to me that the lowest latency connection is the EU server, which you'd expect. The way that works is, just going back to the diagram before, my client device, my PC, has made a DNS query. Traffic Manager has reported back the most responsive server for me. And the way that works is not based on my end client IP address, it's based on the DNS server that I have, so the DNS settings that I have in my on my device. So if you use standard DNS, local DNS, if you get your DNS from a router, usually you're going to get a local DNS server, which means that Traffic Manager is going to check your local DNS server, check the latency, and report back the relevant service that's most responsive to your DNS. Now, it doesn't report the lowest service to your end client. So if you use a global DNS server, for example, if your PC's permanently programmed with one of those global DNS services and it happens to be hosted, for example, in the US, when you do that query, it's going to report back the lowest latency connection to your DNS servers, which is going to be the US servers. And it's going to report back effectively, potentially, a slower service, a slower Azure service. So you're better off using local DNS for this to work correctly. Okay, let's get back to the Azure portal now. And so my PC is connecting to EU. So let's shut down the EU server and see what happens. I'm going to shut that down. So that's gone, and you will start to see that this Azure Traffic Manager service will recognize that that server has been shut down. We might have to forward this video on a little bit. Okay, so you can see that the test endpoint 2, the EU server, is down. Now, service degraded. Obviously my client, my PC, was connected to that EU server. I'm going to bring up a new window, so that's test traffic.traffic. I'm just going to copy that. I'm going to go into a new browser, test.net, and there you can see it's directed me to obviously the US server is the only server that's now up and running. So that's it. So you can use that service for example, for websites, for an RDS farm where you have a number of RDS servers to evenly distribute traffic, or to distribute traffic to the most responsive server. Even if they're the same spec, you might just want to base it on responsiveness. For me, that's a lot better than round robin, or it's a lot better than just allocating an even number of users.